Hello, welcome to PyMOL tutorial number 4. Today we're going to be talking about making movies in PyMOL, some simple ways of doing it and some more complicated ways of doing it as well. So I should talk first about just a little bit of additional software that you might need. In the old days, we used to make movies in PyMOL by generating lots of independent image files and then using FFmpeg to string those files together using a command such as this in order to string like 1,000 image files together into a single video. Now these days with PyMOL 2 point whatever, which we have a university license for, you can just save the movie straight out without having to make the individual images. But if you're doing some more complicated things, then actually making the images is still maybe a viable way of doing some kind of more intricate videos. Also, the file size that PyMOL generates for these movies is pretty huge. So I generally use a piece of software called Handbrake, and on there you can go into the video controls and set the RF to about 24, and that means that your video will be compressed, but the quality of the video remains pretty much the same. But you can probably take the file size down by I don't know, 5 times or something like that. Of course, on the internet there are plenty of resources for finding out how to make movies. On the PyMOL wiki they have a movie school which you can go to, and they have a bunch of different guides here in order to help you out. But it looks like it hasn't been updated for quite a while, so it talks here to make sure you have the newest version 1.2, and of course we're on version 2.4 at the moment. So some of the bits and pieces in there might be outdated, and especially because version 1 was written in Python 2, whereas version 2 is written in Python 3. So if there's any Python related commands in there, they might not function as you would expect them to. So I think we can just dig straight in. How to make a movie using the GUI. So this is normally the simplest way of making a movie. So first of all, we need our structures. So we'll reinitiate our session, we'll fetch our structure, we'll take out our hydrogens, make the background white, we'll make these selections of our ligand and our backbone and our sidechain as we did in the previous sessions. We can show cartoons and sticks for the backbones and the sidechains, color by chain, make our ligand black, add our atomic colors, orient around the backbone, and deselect everything. So we can stick all that in and we get a nice visual such as this, and then we can also add our hydrogen bonds to side chains and backbones as we like. And now we can see here, for example, we've got some dark hydrogen bonds for the backbone interactions and light hydrogen bonds here for the side chain interactions. And now we want to make this into some kind of movie. Well, it's really quite simple. There's a movie tab up here, and the main part of that movie tab is the program and the append sections here. These are really the only two that you need to pay much attention to at the beginning. And there's these little camera loop sections here as well, where you can do a few selected functions. This is, of course, the GUI is limited in the amount of control that you have. So let's just do an example of this. What we can do is, here we are, we're around our ligand here. And what we can do is we can say movie program camera loop, nutate, and let's nutate 30 degrees over 4 seconds. We hit that, and you can see that now we get this purple bar at the bottom of our screen here. And also, if you notice here, where it would normally just say state 1, it now says frames 1 to 120, state number 1. What we can do is we can use our camera controls or our state control function here, and we can just push play, and we do this nutate function, which is just kind of rolling around our particular place of interest. And that's pretty simple. And what you can do is go to File, Export Movie as an MPEG or a QuickTime, and it is really that simple. If that isn't what you desired, and you've made any functions into the movie using the movie tab, you can use the reset button. That removes our bar from the bottom and puts this and removes any frame settings from here. So for example, what we can do is orient on our molecule. We can say movie, program, camera loop. I'm just using mutate. You could obviously use these as functions here, but this is just a nice simple one. Now what we can do is move to a ligand of interest and say movie, program, camera loop, mutate, 30 degrees for 4 seconds. And now you can see we've got 240 frames. So if we go back to the beginning here, you can see that now we can mutate around our entire protein, and then we can mutate around our ligand. Now, that obviously is jumping from one thing straight to the next thing. That doesn't look particularly nice. So this is why we have the append function. So we'll just do a quick reset. We will orient again. We'll say movie, program, camera loop, mutate, 30 degrees. Now, so I've added here a function using the GUI. If I now go back into the GUI and I append maybe 2 seconds to that, and then go back to the program, find my new scene here I'm interested in, and then add my next thing. You can see that now I've got one block here. So this is the mutate one. This is my appending here for 2 seconds, and this is mutate number 2. Now what happens if I go through the if I play the video is we go from here, and in the section that I've appended, because in the movie section here we have the auto interpolate function on, what it will do is it will automatically move the camera between the two views. Now of course you can see at the end of here I don't have an append function here, and therefore it snaps back to the beginning. So of course what I could do is say append another 2 seconds, and you can see that now I've got my mutate function here, my appending here, another mutate and another append. And this time what will happen is we'll go through our initial mutate. The append section here will allow the interpolation between the two views, and then the second one will allow us to go back, and therefore you can make if for example you want a video that's going to loop over and over and over, you can make these kind of quite simple videos just through the GUI, and of course you can have them show something a little bit more interesting than that. And of course if you ever make any mistakes, you just go to movie and then reset, and that will get rid of everything. Very quickly, let's orient. So you have the camera roll, you have this X rock and X roll. So the X rock, I believe, is just a X rotation for a certain amount of degrees backwards and forwards. So there we are, such as that. The roll will just go 360, and then you can do Y rolls and Y rocks, but they're kind of the options that you're limited to here. There are further options, such as using these scenes, which we'll talk about later, and the states, etc. And I think what I've just mentioned this part here, which is using the append function to go from multiple views, and in fact I just described doing exactly this. Now what happens if you have a structure such as an NMR structure, a molecular dynamics structure, or a morph? I haven't talked about morphs yet, but we're going to do some morphing later on in this session, so I can talk about that. But what happens if you have a structure which actually has states in it? Because at the moment, or previously, we've seen, if I show you this one here for example, that if we open up an NMR structure here and we automatically have states here, and then we can play these states. But what happens, how do you play states and play frames at the same time? So, well, one thing to start off with is if you have states in your model, you can actually go straight to File, Save Movie As, and it will automatically save a movie of these 20 states. However, if you decide that what you want to do is do an X, let's do a Y roll over the course of 8 seconds on our structure here, it's not very easy to then tell the GUI to cycle through the states as you're doing this rotation. In fact, you might be able to do it, but if you do know, if you can do it, then I don't know how you do it. So the GUI is simple and nice, but it's not very powerful. What I should talk about are scenes. So scenes, it's got a separate tab up here at the top, and these are very interesting. For example, what we can do here is we can store a scene to F1, and you can see that now I get a little F1 box that's popped up in the bottom left hand corner. And what we can then do is maybe zoom in on a section up here, and we can say as cartoon and make our structure into a cartoon, and maybe make the background white. And then what we can do is say scene store scene F2, and then maybe we want to have a slightly different representation here, where maybe we'll have as spheres util.cbc, and then we can say scene store F3. Now you don't actually need to use these just for movies, you can also just use these maybe for your images or for whatever else. But now what we can do is we can click on F1, and it will take us back to the same camera position that we had previously, but it will also take us back to the same representations that we had put in there. Actually, you notice here the background is still white, even though the background only changed for scene 2. So obviously the background here doesn't change between the scenes. And then we can change to F2, that brings us back to our cartoon view, and then we can go back to F3, and that brings us back to our sphere view here. And what we can do then is, in our movies, we can go to F1, we can say movie, program, camera loop, Y roll for 8 seconds, and then move to F2 and say movie, program, camera loop, mutate for that many seconds, and then move to F3. Let's maybe append 1 second on F2, and then move to F3, and then say movie, program, camera loop, X roll for 4 seconds. Now it's a bit clunky actually, and I think what you need to do is you need to use, I've probably forgotten to do this, but what I think you might need to do is use this update last program button in order to make some of these changes occur. So it is a little bit clunky using scenes in the GUI, but let's just see if we've you see what's happened here is that we've stayed on F3. This is a bad example, isn't it? Okay, now we've now we're in F1. Now hopefully we're going to move to F2, but without any interpolation between the two views, because I'd forgotten to do that. However, using the scenes with the command line is much more simple. So we'll start talking about the command line, because that's where things are a lot more powerful anyway. So what is a state and what is a frame? So you can see here that we've got our 750 frames of that video, but that our original model had 20 states in it, and we seem to have lost those states by making the movie. So how do we control both our frames and our states at the same time? Well, we do that in the command line, and we do that with a function called mset. So whenever you're making a movie, you always need to use mset. So let's just do let's reset this here. And let's fetch in a molecule of interest. So the standard format here is that we say if you have nothing preceding the mset, i.e. you can either have an X or a hyphen. So if you have nothing here, this says start at frame 1, and then if you have X and then a number, it just adds that many frames. So if we say mset 1 to 200, in fact we'll do mset 1 to 150 here, you can see now we've got our little our bar at the bottom that's been added, and you can see that we've added frames 1 to 150. And what this is actually doing is this is saying start at state 1 and add 150 frames of state 1. And we've only got one state in this particular object because we'll keep this simple to begin with. So we've added 150 frames. So this is whenever you're making a movie using the command line, you just use this function here and you just define the amount of frames that you want here. Then we're going to use a second function called mview, and what mview does is it stores the movie viewpoints that the camera is in, and it assigns a particular frame to that particular place. So for example, we can say orient on our molecule, mview number 1, and then we can say mview frame 50, and you can see here I've got this little box here, so this is frame 50, and I've got a box over here for frame 1, and now I can orient on my organic molecule and say mview store 100 and mview store 150. And you can see that now I've got another box here at 100 and another box here at 150. So what we're essentially going to do is we're going to look at our first view from frames 1 to 50, and then because we have the auto interpolate function on, we're going to move from our first view to our second view between frames 50 and frames 100, so that's this middle section here, and then we're going to stay at our final view from frame 100 to 150. So if we start here, we interpolate to our new section, and then we finish there. And that's just a nice simple way of looking at how these movies can work and how to use the mset and the mstore function. It's kind of worth pointing out that the order in which the mstores occur doesn't have to be sequential. For example, we can do a very similar thing here where let's go to movie and reset, where we have the exact same thing, but this time we're going to have our first view at the whole molecule, and we're going to store at frame 1 and store at frame 150, and then we'll move in on our organic molecule and store that between 50 and 100. And what happens this time is we're going to move from 1 to 50, stay at our organic from 50 to 100, and then move back to our other view from 100 to 150. I mean, this is really just to show that the order doesn't necessarily matter. It's worth having a look at the mview page, which is obviously where this function comes from, because in there it has these exact examples that I'm just quickly running through with you. So you can also do this 3D rotation. So we'll just start all that again, and here we're going to say mset state 1 and add 180 frames, and then the beginning and the last frame we're going to be in the same place. Then we'll turn the camera on the y-axis by 120 degrees, set that at frame 60, turn another 120 degrees, store that at frame 120. And if we stick this in, then we quite simply get a rotating molecule. I should point out as well, I didn't mention it here, but you have these power equals 1.0s. If we didn't have this in here, then what happens is the PyMOL likes to smooth the interactions between your different set points. So if we quickly do a reset here, if we used it without those power functions there, then what happens is that we move to 120 and slow down and then speed back up again. And obviously this isn't something that you'd want to have, so having those this little command here stops this kind of jerky movement that you get. So there's some very simple examples of how to do that. Now, some of you, as I say, then will have molecular dynamics movies or NMR structures that you want to be able to show the different structures while moving the camera around. So what we'll do here is I'm loading in, I'm afraid, yeah, I'm loading in one of my own structures here. So you'll have to find one in order to recreate this example. And we're going to do all of our basic stuff of making the background white, defining our backbones and our ligands, and showing us cartoons and putting things into useful colours. Okay, so you can see if we movie reset the movie, good. So this is a file that has 3,125 states in it, and if we push to play here, what this is a dimer to trimer docking session, basically, where we're moving a dimer around and trying to find a part, a best fit for it. So we can reset our view, which we have done, and what we're going to do here, this time we're going to, let's orient, and then I can talk you through the mset. So here we go mset, and we say state number 1. Then we're going to add 30 frames at state number 1. Then if you use the hyphen, what this means is that you want to move to state 150, and then add another 20 frames. So what we're going to essentially be doing here is adding, I guess this is adding 29 frames, because we're starting at frame 1, and then adding 29 frames at state number 1, then adding another 150 frames, cycling through 150 states, and then adding another 20 frames at state 150. I hope hope that all kind of makes sense to you, but we can throw that in, and you can see that we end up with 198 frames here. And then sometimes it's good to state these guys here as well, mview interpolate and mview smooth. I think they're actually set by default, but I think I normally set them anyway, just as part of my scripts. And then we can do some functions. So this is a setting. So here, what we've done here is we've set how the states will interact with the frames. But now we can set how our camera interacts with the frames. So as long as we've remembered how our states and our frames interact, we can then do some other stuff with our camera. So for example, we can mstore frame number 1 where we are at the moment. Then we can turn our camera by 90 degrees on the x-axis. We can store that at state 50, and then we can store state 198. If you store the last frame here, then your movie will start at one place and finish at another place. If you store at not the final frame, then it will auto-interpolate back to the beginning. So you can choose whether you want to have a video that seamlessly loops by making sure that your last mview store is not your last frame, or you can choose to have one that abruptly ends if you just want to play the video once, by making sure that your last mview store is your last frame here. And so we can play that, and we move, and then we start our cycling through our states. Now that's not particularly interesting, but you can make these things a little bit more interesting by again playing around with your mview store and your camera and all of these things. So let's just reset our video here. We shall again orient on our molecule. This time we're basically doing the exact same thing, but we're going to have 50 frames where nothing happens, 500 frames where we cycle through states, and another 50 frames where we're not cycling through the states. And then from frames 1 to 50 we're going to be at state 1, we'll be in one place. Then we're going to turn the camera and go to state 50 and stay there until frame 150. Sorry, I meant to say frame 50 here. And then we'll turn the camera again, wait, turn the camera again, wait, etc. So we'll just throw all of that in and rewind our video, and then we can press play here, and we can start moving through our states. And as those states are still moving, we can then just change our perspective so that we can see what's happening on those different kind of orthographic projections of the thing. And there we go. So that's something a little bit more involved, of maybe something that you might want to show in presentation or something. And you can get pretty ridiculous with how you define this mset. For example, we could use this section here where we know that if we precede our number without anything, we move straight to that frame, i.e. we just abruptly move to that frame. If we proceed with an X, then we're adding frames but maintaining in the same state. And if we have the hyphen there, it means that we're going to move to that state. So for example, here we're going to start at state 1, have 200 frames where we don't move through states, then move to state 78, then back to state 2, so that's in reverse, and then back to 78, then add another 200 stationary frames, move abruptly to state 79, move then to state 156, etc., etc., etc. So you could make these things very, very, very involved, and of course add a whole bunch of different ways in which you're moving the camera around and things like that. As that is perhaps an example of getting overly involved in things, I thought I'd show you this nice function here, which I don't think we've touched upon at all before, but it's called morph, and we can tie that in with maybe a command that we saw before called create. So create just is a little bit like making a selection, but instead of making a selection we make a new object, and because we've made new objects it means that we can manipulate those objects independently of other objects. So this is just a rather silly example of a video, but what we'll do is that won't work with the hash there, so let's get rid of that. Okay, so this is another file here that has got lots of states in it. This is an MD trajectory rather than a docking run this time. So this is chlorotoxin, and again we've got 1,000 frames in here, which we can show our MD simulation for by running through the states there. But what I'm going to do is I'm going to create an object called pent1, which is going to be reduced, and it's going to be frame number 1 of that. So now you can see here that our first object here has 1,000 frames in it, whereas our second object here now only has 1 frame because I've only asked for 1. I'm then going to create these objects, mono 1 to 5, which are going to be the different segments here from my different chains of my simulation. So we can do that. And now what we can do is pretend to denature these things. This is again, as I say, a rather silly example. So if you want to try and denature things, which I mean for the aid of a movie it can be interesting, but it's probably not something you necessarily need to do. So here I'm in my editing mode, and therefore because these are independent objects I can shift, middle click and drag to move those objects independently. And then I went on to the sculpting mode here and put on my auto sculpting, which means that if now I can hold down Control and left click, I can drag parts of my molecule around, and the inbuilt PyMOL force field will attempt to make that happen in a reasonably sensible way. And there we are. So we'll just move these around. Okay, there we go. So now we've completely destroyed our protein. What we can do is now extract all of these monos that we had and call that pent2. And we'll delete all those monos because we don't need those anymore. And now what we can do is use our morphing function. Now morph is actually a really cool, this is probably a really bad example of morph, but morph is a really great tool that you can use to basically shift from one structure to another structure and make some kind of minimization of the interpolation between those two structures. So what we're going to do here is give our morph object a name called morph name, and we're going to morph between pentamer 1 and pentamer 2. If you are going to morph between two objects, those objects need to have the same sequence and need to be structurally identical, otherwise the morph doesn't work. And then we're going to do a refinement here and make 100 steps. This can take a little bit of time here. Okay, so there we are. So now you can see we've got our morph name object here, which has got 100 states in it. That's because I asked it to do 100 states here. And now what we can do is create our full model. So this is again using create, and you can see that previously I was always using create 1-1. So you can obviously go onto the create help page here, and you can see that you've got your source state and then your target state. So what I'm going to do is create full model from the object morph name and add all of the states in there. And then I'm going to smooth my reduced model here. That just takes away some of the thermal vibrations and makes it a smoother transition. And then I'm going to use create with the same model name as before, but then I'm going to add another bunch of frames to it. So now I've got 1100 states. So what I've effectively done is added the morph to the reduced. So now I've got a single object, which is called this guy. And if we play through this, we can unfold it and then get on with our molecular dynamics, which we've smoothed out. So a very silly example, but it kind of shows you what the morph does, is that it computes things, a transition between two objects, providing they have the same sequence. Okay, so we talked earlier about using scenes. Scenes are very cool things to be using, so let's see how the scenes work inside with the command line here. So we'll bring back the dimer trimer coiled coils. Okay, we'll do all of our business here to colour them appropriately, and then I'm gonna I think I'm actually repeating myself here, but let's just go through the script anyway, and then we can orient. Okay, so this section here, this can probably act as a good template for any videos that you're putting together yourself. We're going to start off by resetting our mview, which is I think always kind of important to do. You know what? Sometimes it's actually better to do the full reset there. Here we're going to just set a few basic options here, where we're not going to animate between our... we're going to use the default setting to animate between our scenes, make the animation duration 0. It's a good idea to set your ray trace to 0. I think that's technically also the default setting. So what you will want to do when you're making your video, you want to set this to 0, but in the future when you are saving the video and you want to have it rayed, then you should set this to 1. But bear in mind that if you ray trace every frame of a movie, then it takes an incredible amount of time, hours of which to process. We'll do our interpolations and our smoothing here, and we'll just go through a few things here. So we'll set scene 1. So here what I've done is I've clicked on scene 1. I've set scene 1 and store. This here can be any name you want. You saw before that they were called F1 to F12, but effectively you can make this anything. Then we can do something where we can turn the camera, as we've seen before, and that we can change our representation, and then we can store this as scene number 2, and then again we can change our representation and store that as scene 3. I'm making these representational changes very basic, just for the purpose of the video, but obviously you can make them more intricate as you like. Then we can maybe go to a different scene, as you can remember, if you can remember the set view from before, and then we can save that scene, so scene 004 store. Then we can turn our dimer on. There's our dimer, and we can set that then as scene 5. Okay, so now we've set a bunch of scenes, and we can recall these scenes by going to scene 001 or scene 002 or scene 003, etc. And then we can just do, using our mview before, as previously. Notice also I've set my mset here to have 400 stationary frames to move through 180 states and then have 20 stationary frames at the end. And now I'm going to use the mview and the moving the camera around in order to have a movement through those frames that I have previously defined here. So we'll do all of that. Well, hopefully this is going to work. Let's just see what happens. So here we're going to rotate. This is using these turning functions here with that power. And then we're adding our new scenes and storing them as mviews. And then we're moving to another scene and moving around some other views. And of course this is just something that I threw together as an example, and you can see it's a bit glitchy. It's probably a bad example to use this one as a template, seeing as it wasn't very good, but it has all of the different options in there that's necessary, and you'll just really need to play around with setting your mset, storing your scenes, and then setting your camera functions as you recall those scenes, and you should be able to generate a movie of any kind that you like. So I thought I'd show you an idea of how you can put these into PowerPoint as well. This isn't going to go on the internet because this has got some unpublished work in it. Comfortable with how to make how to use things such as set view and get view and the scenes especially, then you can stick all of this into one file and record your little mini movies in order to kind of push all of these into one nice seamless transition. Complex movies. So again, this is just stuff that I've been doing, and in the last few minutes I thought I'd just show you a few examples of things from the net. Obviously feel free to go and have a look at these things. Now, I haven't talked about setting up a movie panel. I haven't talked about setting the matrix mode, because these are again kind of more involved ways of making movies, and they're more involved to the point that I'm not 100% sure exactly how they work. But you will see that our movie panel down at the bottom will become a little bit more intricate. Okay, so what we'll do is we'll fetch in a couple of PDBs here. We can make them cartoons, which they already are, orient on them, use our mset function here. So we're going to start at frame 1. Start at state 1. There's only one state in this anyway, and we're going to add 100 frames. We'll go to frame 1. We can store our mview there, and what we're going to do here also is to use mview to store these objects. Now, you can see here what this does is it adds a bunch of lines down at the bottom here, so we kind of have an independent movie script as such for each of these objects. And again, I won't pretend that I know exactly what that will help us with, but feel free to dig into that. And essentially what we're going to do is make an alignment using super, which I hope you remember from before. This is a lot like using a line, but it's a superposition rather than a sequence-based alignment. And then we can zoom in on it, store our view again, and then interpolate between those. So what we've essentially got is a before and after of a alignment. I mean, it's kind of interesting, but just a quick example. And if you're doing any of the Python course at all, and you get more au fait with how Python works, then you can even throw in a little bit of Python code into your scripting here. So for example here we're going to set our matrix and movie panel mode again, which again I won't pretend to know much about that, and then we'll bring in our protein of interest, set the sticks, give ourselves 1440 frames, store our view in a particular place, and then we can use this here. And what we're going to do is, because I think there's 144 amino acids, what we're going to do is for each of those 144 amino acids, we're going to add 20 odd frames, zoom in on the carbon alpha of each of those each time that we iterate through, and store the view, and then that's the end of that. And then we can get our final view and interpolate between that, and hopefully what we can end up with. Okay, so then you can get this kind of backbone walking movie as such. So there are quite a lot of different ways in which you can make movies in PyMOL. Some of them are as simple as going to the movie and doing a camera loop and using these functions here, and then you can also start using the mset and the mview tools here in conjunction with the scenes in order to make something more complicated and hopefully more interesting for your viewers. And that, I believe, is everything that I have. So thank you very much.